You can.
Okay.
Okay. So, lesson 6. Oh, and so since we're doing 2 at the same time, do you think we should just do like separate ones? Since I think we're supposed to do that.
Oh,
Anyway.
like 2 different videos?
Yeah, like I'll hang up and then just call you guys back.
Okay.
Sure.
Alright. Great. Okay. So, do you guys have your 6s up?
Yes.
Okay. Alright. Okay. Okay, so part 2. What did you guys get for your mean? I know this is all going to be different, though.
Mine was 45,900.
Okay. Mine was 48,400. Oh, I guess Abby's not even on this thing anymore. Hold on.
Oh.
I mean, back. I didn't realize that till now.
Weird.
Yeah. Okay. Are you there, Abby? Abby?
Mm.
Can you?
Abby? Are you there?
Can you hear me?
Yeah, it's kind of like cutting out a little bit, though.
Okay.
We can hear you now, so.
You guys can go ahead and get started. I'm gonna camp it and see if I can get a better connection because now I have a pretty crappy connection.
Okay. Sounds good.
Okay, see you in a bit.
Alright, bye. Okay, so for 6, then, so we can just say, okay, the with comparing our means.
Mm-hmm.
Let's see, what was B? Okay, that, you know, I guess if we added ours up together and then, you know, took the mean of both of ours, it would be closer to the actual mean.
Yeah. Well, and they're right there in the middle of the distribution, so.
Yeah. Okay. Number 8. I got bell-shaped for A.
Yep, yeah, I just said normal.
Okay, and then, yeah. B, I got normally distributed, and there's a small sample size. C, 529.
Yep.
And D, 35.8.
Yeah, I had 35.73,
Okay.
but
Yeah,
I think that's
pretty close.
close.
Yeah.
Hey guys, I'm here.
Okay.
Welcome.
All right. So we just went over the homework or the preparation, I guess. And do you want to
It's okay. We can go on with
start
the
on the quiz?
yeah,
Okay.
because I checked with that homework.
Yeah. So did I. So.
Hmm.
Okay.
What's her name? Is she not on here?
She was, and she had really bad internet connection and was cutting out a lot and hard to hear, and so she went to G7 campus and then gonna reconnect with us from there.
Okay. Hold on.
Okay, let's see. Do you guys want to wait for her to start the quiz, or should we just start it?
We can start it.
Okay.
Yeah.
Okay. Okay. All right. Are you guys there on it now?
Yes.
Okay.
I'm trying to connect in this thing that it's not working. And lesson 6, right? Okay.
Yep.
Okay.
Yep.
Start.
Okay, so number 3. When taking samples of n when n is 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Wouldn't it be right skewed?
Um,
Because n is not a large number.
yeah,
I think so.
yeah, I think so.
When taking the samples of n equals 100, what is the shape of the distribution of mean histogram when the parent population is right skew? It would be normal, right? Because even though it's right skew, the sample is large.
Yeah.
Okay, number 5. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? Normal.
Well, on the reading, I thought that it was saying that if there's a large sample size, then it's going to be skewed. But or would that just be normal?
Well, it said that if the parent population is normally distributed, then
Oh.
the distribution of means is always going to be normal.
Okay, that makes sense.
Because it's either the parent population is normal, or if it's the sample that's large.
Okay. Okay. Let's see. When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data drawn from a population that is right skewed and the sample is small, and then right skewed and large. So it would be when it's normal, the population that's normally distributed is normal, and then it would be the one that's small, I think.
I don't know. I think isn't it A, B, and just D? We have those lined up correctly. So it's data are drawn from the population that is normally distributed and the sample size is small. That's right.
Uh-huh.
Data are drawn from the population that is normally distributed and the sample size is large. That is true.
Uh-huh.
And then the last one, which is data are drawn from the population that is right skewed, but the sample size is large.
Yeah, I think so.
Yep.
Number 7, which of the following gives the best explanation of the central limit theorem? So A, if the parent population from which the data are drawn is normally distributed, then the sample mean will follow the normal distribution. B is for bell-shaped data, approximately 68 of the data will be within the 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviation, and approximately 99.7% of the data will be within the 3 standard deviation of the mean. It's not that one for sure. If the sample size is large and the sample mean will be close to the population of mean. That's the large law of large
numbers.
Mm-hmm. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. I think it's the last one. Would you say so?
Yeah.
Yeah, that makes sense.
Okay. Let x be a random variable with population mean equals 10 and population standard deviation equals 6. Suppose a sample of size n equals 36 is drawn from this population. What is the mean of the distribution of sample means?
Wouldn't that just be 10? Because that's what the population mean is?
What is the distribution of sample mean? Yeah.
Okay.
Yeah, I think so.
Alright, and then for 9, it's the standard deviation of the distribution of sample mean. So, let's see here.
Oh, so it's 6 divided by
36.
the square root of 36.
Yeah. So that would be 1.
Yeah.
Okay.
Do we need to take the mean over that or anything? No, we don't. Because it would just be.
Yeah.
Okay.
Regardless of the distribution of the population, if sample size is large is larger than 30, what would be the shape of the distribution of the mean sample mean? Would that be normal?
Yep.
The sample size is larger. What shape of it would be large. So regardless of the distribution of the population, so I would say it's normal.
Mm-hmm. Okay, and the last one. What theorem would justify your response to question 10?
Would it be the central limit?
Yeah.
All right.
Should we submit it?
Sure.
Let's do it.
Yay. 100%.
Woohoo.
And then we go to week 7.
Yeah.
Are we gonna just continue, or are we gonna hang up and make a new video?
Oh yeah, sorry, I was gonna do that. Okay, yeah, I'm gonna hang up and then I'll re-invite everyone.
Okay.